So welcome to the third of our public lectures for this year. If you've been before, you will know that my name is Nick Gallant and I'm a professor at the Bartlett School of Planning, and I convene the lecture series. Thank you for coming. Our public lectures are an opportunity for us to bring leading researchers to the School of Planning, or to UCL, for them to provide you with an overview of their research. Often it's very interesting research, and it gives you an opportunity to quiz them on what they're doing, why they're doing it, and how they're doing it. So we've had two lectures so far this year. If you can cast your minds back, we had Franklin Obeng-Odum in October talk about a just political economy in post-colonial Africa. And then just before Christmas, we welcomed Declan Redmond from University College Dublin, who talked about the Irish housing crisis. I'm going to introduce our speaker in a moment, but the lecture series continues after this evening. So some dates for your diaries. We will have Katrina Riddle, who's a planning consultant, talking about the future of strategic planning in England on the 14th of March in this venue. And then we will have Flora Samuel from Cambridge University talk about her work on housing for hope in May, I think on the 25th of May, but I'm not completely certain. And that won't be in this venue, but details will be advertised shortly. And you can get full details on our website. So to this evening's speaker, we're very thankful and very happy to welcome Professor Rachel Franklin, who's standing here next to me from the University of Newcastle. Rachel is a professor of geographical analysis in the Centre for Urban and Regional Development, or CURDS, at Newcastle. She's a group leader for the Livability in the Science of Cities and Regions program at the Alan Turing Institute, which incidentally is based very close by at the British Library, just a few hundred meters from here. So she's regularly around and down in London. Her research is focused on the sources and impacts of demographic change as it occurs at different scales. And she works with novel forms of data to track and understand those changes and arising spatial inequalities. Her work is also concerned with the equitable and just implementation of societal and technological innovations, including smart cities. And that's the focus of her talk this evening, spatial inequality and the smart city. So without further ado, I'll hand over to Rachel, but there will be opportunities an opportunity to ask questions at the end and to have some debate about the contents of the talk. And also beyond those, what do you call them? Those, what are they called? Screens, that's the word, yes. There's wine. So at about 7:30, we will get on to the wine. Thank you very much. And Rachel, the floor is yours.
Thank you. Well, thank you for having me. Quizzes, debates, those are words that make me quake a little bit in my shoes, which are pretty fantastic. You should see the shoes later. I gave a lot of thought to those. I gave a lot of thought also to this talk, which draws together a project which was called Spatial Inequality in the Smart City, which ended up lasting several years, partly because of the pandemic. And so I've given pieces of this talk over the years. This is my first time stitching it all together. And if you've given lots of talks, you're accustomed to competing with background noise. And also you know that sometimes the transitions are really tricky. So hopefully I stick my landing because I'm kind of excited to think about how this all fits together. You know, you start a project and you have an idea, you make a proposal of like what the thing is that really matters, but then you get into the weeds and you just focus on little pieces at a time. And it's only now that I'm able to sort of step back and sort of remember why we started doing this in the first place. And so the project was really about emerging technologies. So everything I'm going to talk about tonight is sensors and sensor networks, which are the sort of integral component of smart city technologies. But importantly, and especially importantly for understanding where I'm coming from, I'm a population geographer. So I'm really interested in how this interfaces with where people are inside of cities. And so everything that I'm going to talk about tonight is how we think about smart city apparatuses, like sensors and sensor networks, and how that intersects with who is where inside of a city. And so in particular, we're talking about concepts like sensor deserts, right? Where are there parts of cities? How do I identify parts of cities where there might not be sensor coverage? How do we even start to think about what that means? Who is it that might be inside these gaps? This is, for me, a sort of enduring question, is sort of who falls into the crevices. And then how can we support equitable decision making? I want to start by saying this was a big team, and I'll circle back to this at the end of the talk. So the team involved a software engineer, Kate Robinson, who's now moved on to a lectureship at Bristol, Jack Roberts, who's a data scientist at the Turing Institute, and Aman, who is also a postdoc on the project and is now on another project at Newcastle. So lots of people coming at this from lots of different perspectives, which I think made it exciting, but it was also kind of a big challenge. All right, so this is a talk in 3 parts. The first is sort of why care about sensors and sensor networks? Why should we care about them? Second is how do we think about and how do we conceptualize coverage when we're talking about sensors? And then finally, how can we support equitable decision-making around sensor placement? Assuming that I bring you all along on this journey with me and you agree with me by the time we hit the third of the talk that actually this is something we should care about, right? So maybe that's a piece of the debate. Maybe it's not really an issue. Okay, so why care about sensors? Well, first of all, they're everywhere. I guarantee that if you walk down the street anywhere in London and you look up on a lamppost or you look in a corner, you're going to see either a CCTV camera, which is being used sometimes just to take pictures of people, but often for data gathering. It's a sensor. They're everywhere. Air quality, noise, footfall, and they've become sort of this integral component of the urban landscape. They're also used, I suspect that my slides are going to be interesting on this big screen. Anyway, sensors are also used to capture ambient noise or pollution that affects individuals, right? And so one reason we care about sensors is simply that we care about what our environment is like, and therefore we want to capture that information. Importantly, though, when we think about a lot of sensors, it's not only the emission, so everything I'm going to talk about tonight is air quality. It's not only the sources of poor air quality. Here's a picture of the Tyne Bridge in Newcastle, very heavily sensed. It's not super heavily sensed because it's a bridge. It's super heavily sensed because lots of cars go over it every day. It produces a lot of air pollution. Therefore, it has to be monitored, right? So a lot of times when we think about sensors, we think about where the sources of disamenities are. We also, though, should be thinking about who's exposed to these disamenities, right? So whether it's air quality or noise, this concept of vulnerability is this intersection between the production of something that is an environmental bad, but also somebody who's there to be affected by it, right? And so when we think about sensors and sensor networks, it's this pairing of what's producing the thing that we want to measure versus who's being affected by it. And sensors are everywhere. Every medium to large city, probably just about everywhere by now, would consider itself to be a smart city. And this is another conversation that we can have. It's a thing that you kind of have to do, even if you don't want to use the data, right? Because you have to be a city that's considered sort of at the edge, the cutting edge of collecting information. A lot of times when we talk about smart cities, hold on, I'm just going to adjust this because every time I turn my head, all right. A lot of times when we talk about smart cities, we talk a lot about real-time data, storing data, edge computing, making cities more efficient, right? We don't spend a lot of time. So this is an example from Chicago's Array of Things sensor network. And if you look at this diagram here, you can see that some of it is about the stuff you want to measure, like environmental sensors or air quality sensors. But a lot of it is about like Linux node controllers. Like that's what lands on the front page of like talking about the array of things. So a lot of it is about computing stuff. Sometimes, but very rarely, is there a conversation about where these sensors got put in the first place. And that's kind of where I came into this. Like, it's just kind of interesting that we spend a lot of time on like real-time flow of data and what we're going to do with the data and the way the data can matter for policy. But actually, the placement of the sensors to start with is kind of important. I hope I'm going to convince you. We have an example in Newcastle. This is from the Urban Observatory in Newcastle, which collects information, if you look over here on the side, on noise, weather, traffic, air quality, sewage. There are beehives also. Usually that shows up here, which is also kind of interesting. So lots and lots of sensors across Newcastle. In fact, the densest air quality monitoring network in the UK. So when I arrived in Newcastle almost 6 years ago, almost immediately was tasked with writing a proposal, and I had to think, what would I want to do? And I had met with people from the Urban Observatory, and I'll show you maps, and I had seen the spatial distribution of the sensors. And as a spatial demographer, I thought, well, this is kind of interesting. I wonder what the underlying, what was the underlying decision-making procedure that led to these sensors being in the places that they're in? And initially, when I started thinking about this project, my thinking was that if it's about air quality and vulnerability, what you really want actually are measures of sort of mobility in cities to understand what kinds of people are coming in contact with poor air quality in different parts of the city, right? Exposure to poor air quality isn't about where you live, right? It's about sort of where you're moving across the urban fabric. And we know this now, right? But then it turned out when you looked at the map of sensors that most of the city is not covered. So it's not even a question of watching people move close to poor air quality and away from it, because lots of parts of the city, we don't actually know what the air quality is. Right? Another reason I think, and this is new material, another reason to think about sensors as being really important is that they're infrastructure. These aren't sensors here. These are like the Graham Bell telephone building in the town where I was born in the United States, but they look like sensors, so I'm including them here, right? Sensors are infrastructure. And that means that they really matter. It means that we have to care about all of the processes that go into generating and maintaining these networks, right? Infrastructure, basic physical and organizational structures that are needed for the operation of a society or enterprise. Think about how much we depend now on sensors to tell us what our air quality is, about footfall, about noise, about how much rainfall different parts of a city are getting. Actually, rainfall is a really good example, right? In the US case anyway, snowfall and rainfall are reported from sensors, and they're often in really interesting locations in the city, because where are you going to collect rainfall, right, or snowfall? In the US, it's often at the airport, which is just an interesting place, right? So you've got to know about the location of where the sensors were placed, because we're depending on this for key data that we use to make decisions about what's too hot, what's too cold, how people are moving, right? And we've got perennial challenges around infrastructure. It's expensive to implement, so we tend to be pretty careful about the decisions around infrastructure. It requires maintenance. Sensors are no different, right? Sensors, once you hang them on the light post, someone's also going to have to go back and take care of them over time. They require a lot of engineering and a lot of planning, so they require expertise. They require a lot of thinking around service levels. Think about transport and accessibility. But equally importantly, we've got issues with equity. We've always had issues with equity around transport infrastructure, around water infrastructure, around electrical infrastructures. So this isn't a new challenge. It's not that suddenly we get new forms of infrastructure and it emerges that we have challenges around equity or spatial inequality. It's that as infrastructures, we're carrying the same problems and the same baggage that we've always had. And we've got lots of new forms of infrastructure that have emerged over the last decade or two, right? And it's a common topic of conversation that inequity is almost baked into many of these, right? If you think about digital or internet divides, that 20 years ago, to have broadband or not have broadband, it was maybe a marker of being well-to-do or being an early adopter. Now it's actually what you need to be able to function, right? In the United States, when schools closed for a lot longer in a lot of places than they did here, libraries had to sort out how to provide, not just provide Wi-Fi, but they had to provide Wi-Fi in the parking lots, because so many households in so many parts of the country didn't have any internet at home, and therefore no way to participate with virtual schooling at all. Right? So you think about how quickly the internet became sort of core, basic, fundamental infrastructure, right? I think we're about to see a lot more around energy transitions and net zero. It's already there. I love reading articles about our electric grid in the UK because it's like, it's not dystopia, but it's almost funny. It's so bad, the challenges that we have around our existing electrical grid, that all you can do is laugh, because if you don't laugh, you'll cry, right? And it's only going to become more challenging. And spatial scale, of course, is an issue here, and I'll get to that a little bit. So it's not only about parts of cities, this city versus that city in the UK. This is a global challenge that we're going to face because we have it pretty good compared to lots of other parts of the world, right? So I think my case is that smart city infrastructures, sensors, networks, data, increasingly they fall into the same category. The more cities lean on the data produced by sensors, the more the sensors become core infrastructure, and then we really have to interrogate it, and we really have to think about how we're deploying these technologies. And there's lots and lots of literature on inequities in smart city technologies, in new technologies. I will say, with a few exceptions, often when we talk about injustice or equity in like big data or algorithms, and so bias, for example, it doesn't have a spatial component. I would argue that the spatial component actually is pretty important at your planners. I'm a geographer. Hopefully we can all agree on that, right? And it's not, as I said, this is not something that's necessarily new. We know that new technologies tend to polarize and divide. It's always sort of funny when somebody pulls up an article about like the horse and carriage and the automobile, and you realize, we've been here before. This always happens, right? Which should spur us, I think, to maybe do better the next time. But we know that smart city technologies privilege some places. They privilege some people and some activities over others. We know that this is magnified at the global scale, right? And I think that we can probably agree that when we talk about data, when we talk about algorithms, when we talk about sensors and sensor networks, all of these have a tendency to let injustice or inequity permeate them, or sort of either be let in the back door or the front door. So what I'd like to do is to get us to think about this and think about how we can do better. All right, so here's the map of Newcastle and the air quality sensors. They're in the city of Newcastle. This is now 3 years old, so they've probably added a few sensors, but this is not, if you were teaching a class on like spatial statistics on the first day of class, you would probably say, this is an example of something that looks fairly clustered. This does not look like a uniform distribution. It's not necessarily a problem, right? Kind of depends where the people are. Maybe all the people live really, really close to these sensors and there's no one anywhere else. Maybe all the sources of pollution are right where these sensors are. But it was enough to get me thinking, I kind of wonder what was driving this, right? And if we put these into output areas or lower super output areas, you'll see that most of the city isn't represented by a sensor. And so this is another point that I'll get to a little bit. When we're talking about coverage, it's kind of tricky to decide what we mean by coverage. But a first cut would be like, does your city or does this local really, really big funded project, does it care about your location enough to have placed a sensor in it, right? And so for most of Newcastle, the answer would be no. Another way of thinking about it is to think about the index of multiple deprivation, which I probably don't have to spend a lot of time on with this audience. It's got lots of critique, but what it does do well is take multidimensional variables and data and give you like a snapshot of neighborhood well-being, right? So compares relative deprivation for over 30,000 small areas across England, with red being most deprived, blue being least deprived. So this is sort of where we were at the beginning of the project and trying to think through, like, does this matter? Is this a problem? And we had so many conversations with engineers, and the engineers said, this isn't a problem. Like, actually, that's pretty much the end of the conversation. This is not a problem, right? But then, if you map the IMD across Newcastle, what you get, and here we've just highlighted, so you can see some of the most deprived neighborhoods, not just in Newcastle, but in the entire country. They don't have sensors. Okay, that could happen. They also all have major roads running through them. That's a little bit more interesting because that sort of starts to make you query the argument that the sensors are placed at the hazard location, right? So then you would say, well, okay, but coincidentally, you've got hazards with more middle-class populations. They've got multiple sensors. And then you have parts of the city that are not covered at all. Okay? So this was where we started thinking, okay, we've talked to some people. We've talked to lots of engineers. We've done lots of mapping. How do we think about coverage? Right? If we want to identify a sensor desert, or say who it is who's not covered in a city by a sensor, how would we do that? And I'm going to take a little, just like hopefully very quick, just to say, quick break to say, it kind of depends what we're observing and measuring. So everything I'm talking about here, air quality sensors, I think of them as pretty non-problematic in the sense that they're capturing information about stuff that affects our well-being. But sensors are pretty problematic, right? Most of what we read about sensors is the stuff probably on the other side, which is stuff that is capturing what people are doing, right? So footfall movement is an example where it can seem kind of benign, but it is also a form of surveillance. You can think about types of sensors in the middle, in this sort of overlapping space, like noise, right? Noise is not healthy. Excessive light is also not healthy. So we have sensors that track these things because they're not good for our bodies. They also, though, are used a lot to police people and to police their behavior. And so everything I'm talking about here is presuming that if you fall into a sensor desert, it's a bad thing. But you could flip it and you could look at who's privileged enough not to be tracked. Who's privileged enough not to have their noise counted if they're sitting on their front stoops at night, right? Or how bright their lights are. So it's an interesting way of sort of thinking about what we're measuring when we're measuring stuff with sensors. Okay. So if we think about types of sensor deserts, the first thing that we started thinking about was, well, what is the purpose of the sensor network in the first place? And there is this division between thinking about network types that are more focused on hazards, in which you wouldn't presume that there would necessarily be good demographic coverage. What you really want is sort of universal population coverage of all the sources of emissions, right? Because you want to be able to track what's happening with air quality in a city. In that case, places where you know there are hazards and you don't have a sensor, so for example, these more deprived neighborhoods in Newcastle, we would think of those as being deserts because we know there are hazards and we're not monitoring those hazards. Another way of thinking about it, though, would be to think about vulnerability. Vulnerability is about the people and the characteristics of the people. We know that some demographic groups are more vulnerable to poor air quality than others. We're not all equally vulnerable. Children, older population especially, tend to be more vulnerable to poor air quality. In that case, what you would want is to make sure you're monitoring where the populations at risk are, right? Somehow we have to bring these two things together, right? There's also thinking about measurement type, all right? And so this is sort of conceptualizing what a desert would look like. There's a material way of thinking about what sensor networks are supposed to do. To me, this is sort of like the representation question, right? If I were an elected official in a city, I might think it fair that my residents would expect me to care about all of them equally, in which case the sensor, whether or not it's collecting lots of information, a little bit of information, there's something about the representation. There's something about being in your neighborhood and knowing that there's a sensor. Again, you could flip this on the other side and think about the policing. Is there disproportionate policing in some neighborhoods over others? In this case, the question is everyone's air equally important, right? So neighborhoods or wards that don't have sensors, we would think that's a form of a sensor desert from a representational standpoint, right? You could think about it from a utilitarian standpoint, though, right? So sensors produce information. Sensors have footprints. This is where things get a little bit tricky, but sensors are much better at capturing the air quality or the noise the closer you are to the sensor. And then in classic geographical fashion, there's this sort of distance decay, and there's a point at which your air quality is not being captured by that sensor, all right? So if you could understand what that footprint is for a particular type of sensor, you would say places, locations, people who fall outside that footprint, they exist in a sensor desert, all right? There's a third type, which is technical, right? So this is if you talk to the data scientists and the engineers, they'll say, we don't actually care about the measurements at the point of the sensor. We're just gonna model this. We're gonna generate a surface, right? We're gonna model air quality as a surface across the entire city, and every single location is going to have an estimate of what its air quality is. This is no problem. To which I would say, I think it still kind of matters where you put the sensors in the first place, but even if you adopt this, right, these models, they come with bands of uncertainty. There's no truth. It's an estimate of what the air quality is. These bands of uncertainty, they also tend to get bigger the further away you are from a sensor, holding other factors constant. So places that have really big bands of uncertainty, you could think that's also kind of a sensor desert, right? It's a place where we're not really sure what's going on in that place. So what we end up with is sensor deserts that are parts of the city that aren't covered, are not represented by sensors, for which knowledge is not produced, right? Not having a measurement of air quality for a neighborhood is not the same as the neighborhood having good air quality. It just means you didn't measure it, right? This is a classic conundrum. It could be where modeling uncertainty is higher. I have just a little bit of math. Because somehow we have to get to, if we're going to try and figure out what the best, where we're heading is what is the best network? What's the best array of sensors in a city if you're trying to cover all the people? To get there, we need optimization algorithms. Okay, so there are a couple I highlighted also to remind myself, what do I think is the most important takeaway on this slide for everyone here? So there are two, right? Actually, there are more than two. The first thing for the people who don't know about optimization or don't really care is that what we're going to want to do is figure out the optimal allocation of a given number of sensors across a city, optimizing on some factor. We're going to care about demographic characteristics of people. We're going to do this two ways. We have a greedy algorithm that just optimizes on one variable. So we say, we've got 100 sensors. What's the best array of 100 sensors in this city that maximizes coverage of the total population, for example, or of all the kids, all right? For reasons, which I will explain, we also use this multi-objective genetic algorithm, which generates lots and lots and lots of networks for us across a series of variables, because of course people sort across space. So as soon as we find the best allocation of networks for kids, it's probably, and it does, turn out that is not ideal for anyone else because the kids are in certain parts of the city. So for decision makers, what you want is a choice where you can sort of show this is pretty good, this is decent across a set of different demographic subgroups. Okay, so key here is figuring out what that distance decay is going to look like. Where do you stop being covered by a sensor? This is really difficult because it really depends. It depends on the kind of sensor, like how nice it is, how cheap it is. It depends where it is. Is it in an area with buildings really close together? Is it somewhere with lots of wind? But also because you've got these issues of representation versus everything else, this distance decay is kind of interesting. So we do this two ways. We do it with a relatively short sort of bandwidth, which is probably more realistic. It turns out like the measurements, they fall off pretty steeply for most air quality sensors, so you really want to be close to one if you want to be sure what the measurement is. But if you're thinking about representation, it's much bigger, right? We go all the way up to 0.5 kilometer on here because it's just, is there one in your neighborhood? Okay, so this theta, this is how we decide on this distance decay. Sensors, okay, sensors have to go somewhere. And everything I'm talking about tonight it's flexible. So these are all the assumptions, laying it out on the table, these are all the assumptions that we had to make. And what we chose was to put them at output area centroids, right? But you could put them on lampposts. It turns out that actual being able to hang the sensor this is where the engineers are right. This is really, really hard. Getting permissions, figuring out who owns different pieces of the landscape, getting permission for maintenance, having it be safe and not have stuff thrown at it in the middle of the night. Turns out this is all pretty complicated. But for our purposes, we use the output area centroids. All right. Okay. So I'm going to show you two examples of two extreme cases. One is the older population. Everything is for Newcastle here. And what you see on these four plots at the top is the difference in number of sensors. And at the top, we have 10 sensors in the upper left and then 55 sensors in the upper right with a very small theta. Right? So basically, you have to be like right there. The theta is 100 meters. more than 100 meters away, and you're not covered. Okay, so it's pretty intuitive. No one's going to be covered. For the over 65 population, we get 4% of the population with scenario A. With 55 sensors, we don't even get to 20% of the population, right? If we extend that theta, that bandwidth for what a sensor is covering, and we move more to sort of a representational viewpoint, right? It's really just like, has anyone thought about this part of the city? That's what 500 meters gets us. We get to 20% of the population with 10 sensors, right? So that's what this is showing here. So most of the city is uncovered. We get to about half of the population, though, with 55 sensors. So already, 55 isn't fantastic, but it's over half the population. The interesting thing that the optimization algorithm is going to do, leaving everything else aside, is it's going to force a little bit of uniformity, right? If you think back on that Newcastle map and how clustered all of those sensors were and how much redundancy there was in some parts of the city, this, from a sort of decision-making standpoint, and I think certainly from an optics standpoint, if you live in the city, is much more palatable. So you could argue that sort of like these technical approaches, they take some of that human decision-making out and in some cases can generate a fairer outcome. The other extreme is place of work population, right? So this is, for the most part, people who are not children and not over 65, but for us was a useful metric because it's as close as we get to sort of where people are during the day, if that makes sense. But also, it turns out it's a really good counterpoint. So we can cover, I'll just skip to the punchline at the bottom, with 55 sensors and this sort of representational standpoint, we can get almost 80% of the population. This isn't a surprise because people congregate when they go to work. That's what offices do, right? They cluster people in small locations, so you can cover a lot of people with just one sensor when they're clustering. What is kind of tricky, though, is that if you compare this sort of optimal best allocation of sensors to the best allocation for the over 65 population, there is some overlap, but there are also some key differences, which starts to point to the fact that there are going to be some trade-offs, right? So you can't just throw one demographic group into the mix and you're done, because you could have competing demands, right? The older population is equally as important as children in a city, and they're not necessarily in the same locations. So what we see as we increase the number of sensors is that coverage gets better, and then it sort of flattens, and we always do better with the worker population because of this clustering bit. If we look at where people are in the city, right? So Newcastle, like many cities, lots and lots and lots of workers in the city center where we've got lots of sensors, if we're the urban observatory, right? But if you look at where children are versus where the over 65 population is, you can see that it's not quite the same. So you would either need more sensors or you would have to make some choices about who you're going to cover with a limited budget, right? And of course, smart city technologies are no different from any other infrastructure. You've got a limited budget. You have to make choices. So the next step is to think about these trade-offs, right? How do we start to think about covering children and the older population? And it's hard, right? If you were a decision maker, this is actually really, really difficult, right? Because you've already got this problem that I introduced at the beginning, which is, suppose you have 55 sensors. Do you put them all at the source of pollution? Like, are they all on the Tyne Bridge? Or do you put them where the people are, at the exposure point? Like, do you put them at schools, right? This is a hard decision to make, and it's a hard one to communicate. Like, how do you tell people this is what we've decided to do, right? We've decided no schools, bridges instead. Or we've decided the older population, not the kids, right? And then you think, okay, but it's also, are we doing sensors for people or are we doing sensors for models? Like, is it about generating a surface or is it about people feeling like they're included in the decisions that the city is making? It really is like, it's like quandaries all the way down. Because is it about sensor quantity or quality? You can get really cheap sensors, but then the data won't be as accurate, right? And this is actually a real trade-off that cities are always trying to make. So what you have are like a few really high quality sensors where you really, really have to have them, and then the cheaper, lower quality sensors in places where you kind of want an indication, but you're not going to get sued, right? Because air quality really, really matters, right? We've got laws about air quality and breaching air quality in cities, right? And then, this is where I'm heading, then you have, well, you wouldn't want to be a decision maker who has to say kids or older people. That's hard to sell, right? So this is a hard decision, and I think it holds for lots of forms of infrastructure. So yeah, I feel really bad for this guy. Okay, so the question is, can we find some compromised networks that maybe are not the best, so they're not optimal, but they're good enough, right? Whatever that threshold is of coverage for kids and for workers and for the older population, can we find a network that hits that threshold for everyone, right? That's what we're going to try and do. And that's, all right. So then, with the multi-objective optimization, what you get, in our case, we get 200 networks, right? So this is just one example of a network. And you get it across all groups. So here's an example of a pretty decent network where we've covered about half of everyone. And it's probably pretty justifiable in the sense that it's nicely geographically distributed, right? So for a start, this isn't terrible, right? And you can also sort of see, you can see what your coverage is across groups. Here, just sort of playing with residents over 65 and workers, the one we looked at before, you can sort of see from these examples that you get of the 200, you get some that are really good for workers. See, it's nice and clustered in the city center and a few other areas, but then you're only covering 40% of the older population. Down to here, where we've covered about half of the over 65 population, which, as you saw before, is about as good as we get because they're so dispersed, right? That's a challenge when the population is not sort of residentially clustered. But when we do that, so when we have a more geographically dispersed sensor network, we go down to covering 40% of the daytime working population because we've placed fewer sensors here, right? Here in the city centers where people are during the day, it's not where they are at night. It's not where they live. It's not where anyone's living, really. Okay, so how does this compare to an actually existing network? I always feel a little bit guilty about this because I love the Urban Observatory. I think it's fantastic. It's a great investment. It does great work for Newcastle, and it's also just kind of fun. And they're great people to talk to. But unfortunately, they are an actually existing network, so we can compare what we get to what they've got. Right? So here are the locations, or were the locations when we started the project of the Urban Observatory sensors. So there were 146 when we did this piece of the project, located in 55 output areas. If you were wondering why 55, why the magic number of 55 sensors, it was because we can then compare it to the Urban Observatory, because we're going to snap all of their sensors onto the output area centroid. So of the 146 sensors, a lot of them are located in the same output area. Output areas are also pretty small, right? So you've got a lot of very small areas that get lots of attention, and lots of areas that aren't getting any attention across Newcastle. So what we're going to do is just estimate the coverage. Using the same approach that we did for total population, we're going to do that for the Urban Observatory and see how well they perform, right? Because that gives us a point of comparison. So we've got total residents, under 16 population, over 65, and workers. Anywhere where you see orange on the map are areas that are sort of underserved by our metric, by the existing Urban Observatory network. Anywhere with purple would be sort of excess or redundant coverage, right? So places that are overcovered. So here, because there are so many sensors in the city center, you're not really covering any of the older population, because they don't live there. So you've got lots of redundancy here, and then you end up sort of underserved. I mean, a takeaway here, whether you believe in optimization or not, is that you can come up with tools that force you to distribute sensors or infrastructure or access, right? There are ways that we can sort of trick ourselves into being a little bit more equitable, or at least stress testing the decisions that we're making by default. When we generate those 200 networks and compare it to the Urban Observatory, so the Urban Observatory is this black line at the bottom. So that Urban Observatory network, when you think about coverage, right, covers relatively small shares of the older population, kids, even total population, but it's really good at covering place of work, right? Not really a surprise because there are so many sensors in the city center. What was kind of interesting is that these are our 200 networks across these 4 categories. All of our networks, every one of them performs well better for any of these first 3 categories. And even for some of our networks, we're better on the worker side, right? So, yeah, so for us, this was sort of an affirmation that maybe the optimization approach is a worthwhile approach. So what do you do with that? Like, this little batch of slides here, I've now talked through several times. Everything from like theta, like the optimization piece, through to here, I've talked through. And when we were doing the exploratory analysis, as we changed things, it's still kind of complicated. Like this, yeah, and this is also like the 3rd visualization that we landed on, because a reviewer was like, did not like we had beautiful swarm plots that were so appealing, and the reviewer hated them. So this is why we've got this. This is reviewer approved. But even this, like, it's hard to talk to people who don't know what optimization is. Theta's a problem, right? It's just like, there's just like no way to convey a Greek symbol to most people in the world. So all of this is kind of hard. Like, I think it's really useful, but it's not easily translated into actually doing something in the real world. So that's the decision-making piece, right? So how do we support decision-making? This was really fun for me, because this is where the software engineer came in, right? Because we have, essentially what we have now is all the stuff on the back end, but we need something that's visually appealing on the front end that like a more average person might be able to engage with, right? Either a local resident or a planner or some kind of decision maker and a local authority. And this took a lot of time, right, and a lot of working through. But what we want are tools that help us create better networks, right? I care about the equity piece, and I care about it from a demographic standpoint, right? I would like to build tools that make it easier to make sure that we're maximizing coverage. Maybe we can't reach full coverage, but we should be trying to maximize coverage for different sorts of groups, so that everyone's benefiting from this infrastructure. So I'm just going to walk. I'm not going to do a live demo, because that would not work probably. And I'm only going to show you a few screenshots. But I'm going to like highlight the stuff that I think is really cool. So it's a decision support tool that is all about helping decision makers place sensors across the urban fabric, right? Assuming that this optimization approach is a good one. So in the prototype, we have our 4 variables, right? So we have total population, residents, under 16, over 65, workers, a choice of number of sensors, and then a choice of what this bandwidth is going to be, with some explanatory text to help guide some understanding of what theta means, but sort of landing on this, like, do you care more about the accuracy of the measurement for air quality? Do you care more about representation? And that's going to help you decide sort of how big you want that catchment area to be for a particular sensor. When you run it for one variable, right, you get your 200 networks, which you can then click on in the plot, and the map will change. So it sort of shows you, if you want to know what a network looks like that covers a relatively smaller share of the population, what does that look like spatially? And remember, people who live in Newcastle, decision makers, are going to be much more familiar with the city, right? We can collapse it into IMD, census variables, lampposts. but people who are familiar with the city will have a much finer grained sense of what is actually going on. So for every one of these, you can see where the sensors sort of move around. You can also pick up a sensor and move it and recalculate and ask yourself, well, what happens? Like this, suppose you're pretty sure that here there just has to be a sensor, and you're kind of curious what's going to happen with coverage. This, to me, was sort of where I wanted to be heading, because I'm not sure that, well, we did lots of interviews with local authorities and with engineers. There are lots of urban observatories in the UK. And I would say maybe half of the people we talked to really wanted a tool to help them place air quality sensors, right? So this would, where people said, this would be great. If we only had this would be really useful for us. The other half of the people, what's more useful is the walking through the decision-making process. Like this renders decision-making much more transparent if you're able to show people, look, this is what happens to coverage when we move a sensor from here to here. This is what an array looks like. It allows you to compare, right? So I think from a transparency standpoint, it's really nice. And if you add in other variables, and again, these are the ones that were for us most convincing in terms of air quality measurement and easy to get. The tool, the optimization, and the interface are super flexible. So you could have lots and lots of different kinds of variables that you're maximizing coverage against. But the nice thing when you have multiple categories in here is that you can sort of see as you click on a network, it will show you on the map, but it'll also show you where in this distribution does your particular network fall for different categories, right? So if you choose one that's, I don't know, really good for workers, it's going to show you, okay, you can do that. You can maximize coverage for workers, but your coverage for other demographic groups is going to plummet. And you can get lots of these sort of middle categories. And as I said, you can sort of move sensors around. There was a lot of, this process was a long process because there was lots of showing the tool to people, having them try it out, hearing what wasn't working. So this is not where we started out. Like where we started out was something completely different. For example, I don't think, so when we started out, I thought we should ask people to choose what kind of sensors they want. Well, that turned out to be like a no-go. I mean, the technology changes so quickly and brands, and even a price of a sensor. But I thought, from my perspective, knowing your overall budget, like I've got 20,000 pounds to spend on sensors, how many sensors can I get? That to me seemed like kind of a useful thing to walk through, right? You want some expensive ones, some cheaper ones. Turned out that was just complicated and nobody wanted to think about it that way. They just wanted numbers of sensors. Okay, so I'm gonna slowly wrap up. All right, so I'm pretty attached to my optimization approach, as one would be after a 4-year project, because you get pretty invested in these things. So I'm happy to be quizzed, and I'm happy to have debate about it. Of course, it's close to my heart. But what I would say is that what's really important, more important maybe than the optimization, is just thinking about what's the purpose of a sensor network? And it's not only like, is this for noise or is this for air quality? It's, as a city, what are we actually doing with these sensors? Like, is this just so that externally we're shown to be a city of the 21st century? I mean, I think that a lot of cities, that is the purpose. The purpose is to show that you're not behind the times. You're modern, because if you're modern in this one thing, it conveys all these other things about what your city is also doing. Okay, be honest about it. Think it through. Is it about air quality monitoring from the source? Like you've got a Tyne bridge and you just need to keep track of that. Well, then talk about it. Is it about keeping track of people? Well, then you also need to sort of think it through. The sort of, one of the engineers that we talked to about like, why are the sensors where they are? They said it's an ad hoc process. And I thought, well, that's probably the one thing you don't want. Like you can do anything else, but the ad hoc process is not delivering on anything, right? It's just not delivering on anything. So I'll leave that there. And I think the optimization tools, they're pretty cool. Like people love the idea of best, but even just good enough, and sort of like the way it uses geographic space and the way it forces you to think through constraints and what it is that you're optimizing on, what you really care about, is an exercise that I think is really useful. And visualization, right? So decision support interfaces, it's the working through, right? It's not just the delivery of the solution. As I said, I think that's interesting. For me, it's actually that working through process. Well, here's what's happening. If we do this, then we get this. If we do that, then this is how it's going to look. That, I think, is really helpful. And as I said, I think it really helps with the transparency of decision making. We've tried to think a lot about this surveillance and bias issue around sensors, and I think so where I've landed on this is actually that the air quality sensors, they get buried so low down in the discourse about sensors. Almost all we talk about are the bad sensors, right, and how terrible sensors are. But sensors are doing really, really important work, and if you're anyone who cares about environmental justice, you should care about this because we know that it's certain populations that are disproportionately impacted by poor water, poor air, poor everything. And unless we measure it, we don't know it. So somehow I think in all of this smart city discussion, the good work that sensors can do gets lost in this sort of muddy conversation. So I think keeping our eye on that is important. Yeah, and then circling back to where I started with this project, it'd be really nice to actually know who's moving around the city. I mean, yeah, every total population, children, older population, those are place of residence. This is where people are at night. And even if you assume that the older population is home, like as soon as you turn 65, you don't leave home, that's a pretty big assumption. We know kids aren't home during the day, right? So what you really would want is something that gives you a better indication of what kinds of people are where in the city so that you could actually get a better sense of what coverage would we need to make sure we've got a pretty good picture of the exposure that kids have to poor air quality. And I should say, there is a piece of the Urban Observatory that had sensors at schools because that seems obvious. It's like place of work, right? You just put sensors on schools. And it turns out that you can kind of predict which schools got the sensors, right? So it just reinforced all kinds of other inequities. I mean, it's good, but really you need every school to have sensors, not just the schools who had somebody who was willing to write and say, yes, please give us a sensor. We'll organize a time and a place. We'll do all of that stuff. It's a certain kind of school that's able to do that, right? So that's not the only solution. Citizen science in Newcastle, again, another arm of the Urban Observatory, would sort of lend sensors to neighborhoods. You can also predict what kinds of neighborhoods had those. So it's a complicated challenge, which I don't think means we shouldn't do it. It's just really interesting to think about the ways in which inequities get sort of hardwired through all of these ways in which we're trying to be more inclusive. And optimization doesn't do that. So this is an example where like the machine actually can do better than the human in terms of being fair, because our other processes, they're not necessarily going to work without, a lot of work. Okay, some final thoughts. This is my last real slide. Yeah, multidisciplinarity. I couldn't have done this without people who were data scientists. One of the postdocs was a planner. Another one was a geographer, a research software engineer. And it was interesting, and I'm happy to talk more about this, but it was not only the magnitude and the scope of what we were able to achieve over the course of the project, but it's also sort of learning how to work with people and what they care about, what they don't care about. Like the data scientist and software engineer, papers, crickets. Like you'd say, here's a draft of a paper, can you read it so we're ready to submit? Can I have your permission to submit this paper? And nothing would happen, which is not what happens. Like I assume if I wrote any of you and said, here's a paper I'm ready to submit and you're a co-author, can you please give me the thumbs up? Not even edit it, not like just say, yes, Rachel, this is, they didn't care because it's not necessary for them, right? So there are all these other ways of working with people, whereas they really cared about the prototype. Right? They cared about having the prototype ready and able to share with people. So the multidisciplinarity, I think, we're always saying this is how we should be doing research. For me, this was the first example of sort of managing a team like that. And I have to say, it was pretty fulfilling, complicated, but really interesting and fulfilling. The other thing, though, when I was thinking about all of this, because now the project is done, was it's so nice to have long projects. Like I was on a panel today for an ESRC funding call. It's for 10-month projects. You can't do anything in 10 months. You just can't. But you have to sell it. Like for everyone, it's just like, you just think about like the sunk cost of like me, my time, the people who are going to write proposals, the reviewers, for everyone. And it's fast. It's like this fast science. This was an example where we just had, because of the pandemic mostly, we had so much time to work through options, to try out different algorithms, to spend time on the prototype, to talk to lots of different people. And so for me, even more than the multidisciplinarity, the really interesting thing was that it's just kind of nice to take your time on stuff. And I think we've forgotten, some of us, I definitely have, all these other pressures to be fast and get stuff out, that if you take your time, it turns out that a lot of times it's more fully baked, I hope. You're probably the judges of that. Yeah, and this sort of data equity interface. I mean, the smart city infrastructures are one example of so many different avenues in our lives where you've got this data and equity clash, right? In this case, to me, it's really emphasized that it's not just about data. And we know this for a lot, like you can separate for, like image recognition, for example. You can separate the algorithm piece and then the training data, right? So that you often have these, you can decompose sort of like what's causing these inequities. But in the case of sensors and other forms of infrastructure, it's not only the data. It is where the sensors are located in the first place, which is a decision that just gets skated over, right? That nobody's really thinking about that. What they're thinking about are what they're going to do with all that stream data, right? And all the cool things that you can do, like navigating around, avoiding crowded places, avoiding places with poor air quality. But you only know if it's a neighborhood with poor air quality if it had a sensor. Otherwise, we don't know that. And it's really easy, right? I think this is a really good example of how easy it is to just have the inequities get built into that infrastructure without having any extra thought. Yeah, I think spatial inequality, I first typed it's an important lens, and then I thought it might be like the dominant lens. I think for me, spatial inequality is just, it's everything, right? It's the inequality piece, but looking at how these inequities and inequalities get replicated or articulated across space. And it matters for neighborhoods, it matters across countries, and it matters globally. And we can have new infrastructures, but we'll probably still face the same old challenges. And then lastly, sort of thinking about how to make research useful to people. I mean, I think I kind of already said that and sort of talking about this decision support tool, but that I think is really important work that we can be doing. Thinking about what we get as outputs, whether they're words, whether it's narrative, whether it's pictures, whether it's models. How do you go that extra bit to tell people, here's what I think this means, and also here's what I think you should be doing? That's harder, but it's also really exciting, and it's, I think, really important work. And with that, done.
Okay, we definitely have an opportunity to ask questions. I mean, I have a discussion point for you about the merits of short projects versus long projects, because I have a very short attention span. So my projects have to be very short, but we can do that over dinner. I just wondered as well, I mean, I had this question about these deserts and whether communities would prefer to be in a desert sometimes, and you answered that question. But have you engaged with communities themselves about, how they feel about these sensors and whether they would prefer to have them, or what's their level of enthusiasm, what sort of sensors they would not prefer not to have, etc.
So it's a recurring theme in the literature for a lot of forms of sensors that it's a way in which populations end up being policed. And that's sort of like where I started and where I ended in the talk, is that I think somehow we have to extract the sensors that are doing work for measuring the stuff that impacts us as not being the same as measuring us, right? Measuring air quality is really important. Measuring temperature, right? I mean, some of these are really basic variables that sensors collect for us that matter. And I don't like to see them sort of subsumed under this bigger rubric of sensors being problematic. That said, in our early conversations with the engineers about why are there no sensors, like why does Walker not have any sensors, the engineers said they had sensors. They had sensors 3 times. They had sensors 4 times. They don't last. And there are only so many times that we're going to go back into a neighborhood and reinstall this really, really valuable piece of equipment. So then, I suppose, and so we didn't do this, but then it sort of begs the question, like, okay, so a big piece of this, I mean, if you think this is the way we're going, and it is the way we're going, this is how we're going to, well, I think for the time being, this is how we're going to measure a lot of these environmental variables that we really care about. So then it becomes a different kind of conversation. It's less about technology, it's more about talking to people and figuring out is there a way to persuade people that this is something they should care about? And I don't know if there is, but that's, I think, where the effort has to go. The effort has to go towards convincing neighborhood groups that this is something that is to your benefit.
Is there a sort of distinction between sensors that can see them and sensors that can't see them? I.e. cameras and surveillance.
Yes. Yeah.
Or sensors that know how fast they go.
Yeah. Somehow I think articulating what environmental sensors are doing and why they matter is important.
So we're going to take some questions. I have a couple. I'm going to come around. We need to use the microphone so that it's picked up for the recording. So I'm going to come around with this.
Thank you very much for that. I thought it was really interesting. I got two questions. The first one, you talked about the ad hoc nature of the infrastructure, which I can imagine the processes led to that. In your conversations, was there really any sense of will to, as it were, move sensors around to create the ideal network? And my second question was about, this is about fixed sensors, networks of fixed sensors. With technology, we've got more and more portable and wearable sensors, mobile sensors, either sort of citizen scientists, moving a mobile sensor around different places, or you could imagine putting some sensors on, onto kids' book bags and collecting data. I was wondering if that was something you'd thought about and what the implications would be of shifting towards a focus on more mobile sensors.
Yeah. So I'll take the first question. So yes, there are sensors that can be moved, and that is pretty common. And you probably have seen, maybe in your neighborhood you've even seen, like for speed, in the US this is common, they'll put a little sensor up that shows cars as they go past how fast they're going, partly to tell people to slow down, but also to collect that information. And those are mobile technologies. They serve a purpose. The challenge is that, speaking for air quality, a lot of what we want to know about the sort of shifting surface of air quality is around, I have a few examples, like a road closure, construction, congestion charging. These sorts of scenarios are actually about like before and after, which means that you have to have fixed sensors that are able to capture what was going on before the change was implemented, so you can see what the sort of spillover effects were elsewhere. This is really relevant for congestion charging, where you like to think that it's going to depress overall traffic volumes, but actually a lot of times it's just people taking a different route. So neighborhoods that didn't used to be impacted by lots of traffic now are. And so you could do this with a set of mobile sensors. The challenge is the same, which is that you've got to think about what the purpose, like what is the purpose of this network? If the purpose of the network is for evaluation of policy changes, then you need to design your network in such a way that it's going to be robust to that. And I don't think in general that is the way sensor networks are being designed, right? So when I talk about sensor network purpose, one of them can also be for policy evaluation, but that should be a conversation that you have where you say, okay, we really need to know when we do this what happened in the system, and then you have to have those sensors in place before that external shock is applied. Wearable sensors. Yeah, I think I'm not hearing as much as I was 3 years ago or 4 years ago, but I think, I'm a highly sensed person. I let my watch tell me everything about my body. My phone is probably telling me everything it can about my body. So we're definitely heading in that direction. To me, it's a little bit like letting charity feed people who can't feed themselves. I think the state has a role to play here, right? This is data that really matters. Temperature data, for example, or precipitation, air quality. These are variables that should not be left to individuals to decide to opt in. This is something that needs, I think, it's infrastructure that needs to be in place for everyone and not depend on those who are opting in and opting out. The other thing I would say, though, is that I think the problem with all sensors is that they're point-based, right? If we can start to think about ways of collecting information that are not point-based, that it might be more field-based, for example, satellites, right? And once we can satellites are going to get really, really good. They're already pretty good for temperature, for precipitation, for knowing when stuff is green, when it's not. As soon as we can figure out with a high degree of confidence air quality, we won't need these clunky sensors because they're not ideal. I mean, they're better than not having anything at all, but they're not ideal. There's no way you can have uniform coverage. I mean, this is basic geometry. There's no way. It takes an infinite number of sensors to cover every point inside a city. So it's not an ideal infrastructure. So hopefully we leapfrog at some point.
Thank you very much for the presentation, and really got me thinking in a very different way about the planning of cities. I just wonder if you could say a bit more about the place politics, just to follow up on Nick's point. I'll give you an example. So here in London, as you may know, there's a huge debate about the ultra-low emission zone being extended. In southeast London at the weekend, I went for a walk. Every single traffic light with a sensor on it had been cut down by somebody with a chainsaw. Right, the level of infrastructural violence was quite shocking, actually, to be honest. I mean, you see these things in your neighbourhood. Now, what's interesting about that is it's the opposite of what you're saying. It's relatively privileged groups demanding to live in a censored desert. They want desertification, to use your language, of the censoring. And in fact, I thought a lot of research showed that one of the great privileges of having more income is your ability to buy your way out of being monitored.
Yeah.
Right, for example, billionaires fly into Biggin Hill Airport, they don't even show a passport, right, in London, whereas I have to show a passport because I'm not a billionaire, even though I'm an academic. So I just wonder I just think about the politics of what you're saying, because you seem to be implying that censoring is a progressive thing. A lot of people would pretty fundamentally disagree with that premise. I understand in the context you were saying that it can be, but I want to say just a bit more about that kind of place politics and how that works in Newcastle.
Oh no, all right, hold on. Here, I thought I was gonna be really clever and just, so this is why, this is why because it's like two sides of the same coin, right? Being in a desert is either a privilege, right? Not being, the freedom to not be monitored, or I think this is the argument I'm trying to make, or in the case of air quality sensors, you really need to be. Like you want to be. You want to know what your air quality is in your neighborhood, right? Yeah, well, but you also want to be able to drive your car wherever you want, right? I mean, I wish that I had more to be able to say on like the what do you call it, place politics of this. Yeah, I mean, it sounds like I'm going to veer like out of academic to just like personal opinions. But these things are all, they all intersect with each other, right? I mean, there's all this, like so many conversations about people driving their kids to school and the air quality at schools because of the cars lining up, but very little effort to make sure our infrastructure and everything else is in place so that kids don't have to be driven to school, right? So we've gotten ourselves into a not great situation on lots of fronts.
Hi. I'd like to go back to a thing you alluded to a few times but never really sort of expanded on. Like, you talked a bit about how what the ideal process might be for placing sensors, and you said that the actual way that sensors were placed was ad hoc. Did you find anything out about how those decisions were actually made and like what led to that distribution of sensors in the real network?
So in looking at different cities, well, so there are lots of different ways that cities implement sensors. So sometimes it's city government, sometimes it's private, right? Sometimes it's funded research, so like the Urban Observatory. So there's a lot of variation in how a city comes to have sensors. I think that from comparing different cities, and this was not a census, this was just sort of like looking around to try and see like, how is this done? There are places that are very deliberate. There was definitely one iteration for London where like the first sentence was like, every borough will have like every place is going to get to have a sensor. Chicago, Array of Things, actually also had a lot of language around making sure that there was a process for lots of places to sort of opt in. And if you, our first paper was in transactions of the IBG, and is really pretty descriptive, but it compares Newcastle and Chicago on different variables, and you can see it's just much more equitably, sensors are much more equitably distributed across Chicago than they are in Newcastle. So it matters sort of that intent before you start. In the case of Newcastle, in total fairness, I think if you start from the premise of like where are the heavily trafficked zones of the city, or the places where we know historically air quality has not been good, let's start there, right? And then you sort of say, okay, well then in the city center, we should probably also make sure we've got sensors. Those are highly visible there. Like, you know, if you want to make sure people see that this project is happening, that's probably where you're most likely to have people notice it. So I think it's that initial bit where you're sort of deciding, like, what is the purpose of the network that should help to carry it through? And then it's piecemeal from there, right? Because there's not necessarily a lot of continuity over time. Sensors get broken, they go offline, you have to replace them, you know, you had permission somewhere. But I think that first decision is probably going to determine a lot of the equity. Yeah. I don't know if I'm answering you. I feel like I'm still, from your expression, I'm still skirting it.
I think what I'm wondering is there a possibility that actually this is quite a well-designed network but it's based on the idea of hazard sensing rather than vulnerability sensing?
If you agree that it should be super redundant, like you need lots of sensors for one location. And I think from the Newcastle case, I would push back because we could see that there are lots of places where we know the air quality is not good, and you would think there would be a sensor, and there isn't, right? So to me, the hazard approach works. Like to say, yes, there was a master plan here. If all the places that are hazardous have a sensor. But if that doesn't hold, then it sounds a lot more ad hoc to me.
Right, but I was wondering if you'd evaluated that specifically.
No, we had a lot of conversation about how to do that. So I have to say, they did not say that they chose all the hazards. So at no point did anyone say, this is why you're seeing the pattern. So we were told ad hoc. So just to be totally clear, nobody said, we did some research and here's where all the hazards are in Newcastle. That's not what happened, okay? But then we did have, so there was a whole stage towards the end, once we got into the decision support tool, where we wanted to get a sense of like, where would be, like this, you know, it's the button between sort of hazard and vulnerability and exposure. To get to vulnerability. And we wanted to have estimates of like where should you be placing sensors based on poor air quality when you don't know. And you can, the direction that we headed in was to sort of look at intersections and look at traffic flows, and just to assume that if you've got several lane roads and lots of throughput, that's going to produce poor air quality, right? So you just look at the street network and you look at the traffic, and then you get these estimates. Wasn't entirely satisfactory. But so we did think about it, and it's a missing piece, and you could totally factor it in, right? You can actually have that be a piece of your trade-off, like that you want to maximize, to do the best possible coverage that you can for sources of poor air quality alongside all the demographic stuff. So there's no reason that you can't do that in this framework. It's just that we didn't land on a good way to do it.
I think he just asked my exact question, actually. I mean, I was amazed how anybody could design such an incompetent network as in Newcastle. And I just, you know, so I was going to ask exactly that question. You know, how did they possibly design a network which didn't seem to measure anything, hardly anything compared?
So I think it does, I think that's probably unfair. And it's easy for me to pick on engineers because they were not interested at all in the demographic side of things. But I think,
you know, you said yourself that the critical thing is to think about is where you're going to place these sensors. And you would think that was the first thing they would think about. You know, we need to measure the population. So we need to think about optimizing the network. You think that would be the starting point for anybody?
Well, I think so. But I also think that there's the reality. So suppose you're a funded project where you've got money to place this number of sensors over a certain number of years, right? You're really excited. You've gotten the funding. And I don't know if this is what happened, but it would certainly be the case if it were me. My first thought would be like, holy shit, where am I going to put the sensors? right? And then I would go out and try and place the sensors and realize, oh, no one's going to let me do this, right? This is actually going to be really hard. And we had, at the beginning, we had a long conversation whether we should just use all the lampposts as potential candidates for where you would put a sensor, right? But that doesn't work either because you get some lampposts where you can. Like this permission piece is really big. So you start, I can imagine that you start off and you've got the budget, but you have to get going. You have to show pretty quickly, right? This is a funded project. You have to show pretty quickly you actually have sensors out there streaming the data because the first thing anyone thinks about is the data streaming, right? How many readings of air quality are being produced? Like that's a metric, right? That's a metric that everyone uses. We get, every 20 seconds there's a reading of air quality as opposed to here's the boring part, which is that we thought about where we were going to put the sensors. So I can see how it happened. And it does give good coverage of city center. And I think it does cover some of the Tyne Bridge is a known, and all the motorways, these are known problems in Newcastle. So they did do the big known problems. It just gets kind of interesting when you go up the Great North Road in Newcastle. That is also, so an interesting thing about Newcastle is that we have a very sort of high air pollution road in a very middle class neighborhood, which is kind of unusual. So they get lots of sensors. But it's sort of this interesting paradox because a lot of times you don't get that intersection of middle class and roads that spew a lot of stuff. But we've got that. And so that explains a lot of this sort of corridor going north. It's not that the air quality is good and it's that they thought the air quality is bad there. We know the air quality is bad. They'll get sensors. Yeah, I think optimization is the answer for a lot of things. It doesn't tell you it's not the answer. It's not like, the number 42. It's just like, here's a good starting place. What's the best that we could do? And then you tweak it from there. And we've moved a little bit away from some of those technocratic approaches to making decisions, I think. I'm not a planner, and I'm not an engineer. I'm just a spatial demographer who's kind of curious about coverage of people. So that, full disclosure. But I think optimization, a lot of these tools that we used to lean on much more for service provision, they do good work. Yeah.
First of all, thank you for the presentation. I found it really interesting. And I have two questions. One is regarding you are actually trying to find the optimal way to locate sensors, but you are not considering, it's like typology agnostic. So there are different type of air quality sensors. So sometimes you can just measure, carbon dioxide, or you can actually measure, for example, black carbon or the kind of factors. So we are not actually considering which variables needs to be measured. And then a second question is also the governance of the data we are gathering. You mentioned before citizen science, but we have a lot of sensors. What's happening with this data? Can we actually access to the data, and how, actually?
Yeah.
Who is benefiting from the data itself?
So at the beginning, I thought I was going to be much more interested in different kinds of air pollution. And then this location thing happened, and I haven't really given any thought at all because I'm kind of hung up on where the sensors get placed in the first place. This production of data. Okay, so this is a whole other, when I had that slide of all the literature on inequities in smart city technologies or new infrastructures, the production of data is another one. So Urban Observatory, it's free. Anyone can go. You can sit here right now, but good luck. It's complicated. It's partly it's the magnitude of data, right? And we'll get there. I think because people care about these things and people care about equity, I think that we will do much better as a research culture, as a society, as governments. But at the moment, it's really hard. If you just want to know, how bad is the air quality in my neighborhood, for a lot of these sensors in a lot of these places, you are getting a reading every minute, right? And then sometimes it drops out and it doesn't give you a reading. Sometimes it gives you a reading that clearly isn't valid. You have to have a lot of sort of, you don't have to be an expert in the variable itself, but you have to be comfortable with data to sort of see something that a baseline, or see something that goes like this and realize, oh, during the day it's going to be here and at night it's going to be here. I'm going to have to think about how I average this. It's a lot of data, so you have to figure out where are you going to put this data? In your downloads folder? So it turns out that I shouldn't say almost all, but a lot of these cities, it's like any other open data source. It's there. That does not mean that it's equally easy for everyone to access and make sense of, right? And it is also a real thing. Like, what if, also, like, you have to be able to decide, like, if the sensor is a mile away or a kilometer away from you, like, is that your sensor? Like, does that count? Can you use that? I wouldn't be able to answer that question for myself. I mean, I would know enough to be sort of critical of it, but I wouldn't know the answer. So it's hard. I think this is actually why the schools thing is kind of cool. So to go back to the sensors in schools, if all schools had them and all schools had the resources to use them, this is where these projects, I think, start to be really interesting and useful, because you are helping people engage, teachers, not just kids, but also teachers, parents, everyone thinking about, wow, this is hard. Like, what kinds of tools and skills do I have to be able to work with all this information that's going to be thrown at me, apparently, for the rest of my life? And that might help us move faster towards how are we going to do this? It's just that's really hard. Schools don't have these. I mean, this is just one example of like something that happens all the time to schools, right? Something is foisted on them. Nobody has the time to be able to do the thing that we think they're going to do. Yeah.
It's really a fascinating topic, and it does have a lot of politics around it. But if we're just sort of holding equal that this is going to be used as a public interest decision-making tool, I just wonder to what extent you've built into the analysis the nature of the decisions. So when I've been looking at clean air, I've been looking at the use of data for regulatory decisions. So very hard-edged legal requirement to have data, in which case it does make sense to have it in the most polluted areas.
Yes.
But the other thing I'm thinking about is whether if there's another layer in the data that might sort of be a next stage, which could be to do with health, because this is a health concern. And the reason I ask is I fully buy into the spatial inequalities considerations, but as soon as you consider a health or an epidemiological perspective on this, the people I work with in the Institute for Child Health tell me very strongly that you have to prioritise the young because it impacts their health differently. They have different risk. So it's just a thought.
Yes. So the regulatory piece, I totally agree. And actually, I think this is why this is why networks have to be designed. This is why you have to actually think about it, because we have rules. But how do we know which places have poor air quality until we've actually measured their air quality? This is the thing that really gets me. This is a production of knowledge question. Like this is how are you supposed to know unless you've taken a lot of measurements around the city at a lot of different times of the year and a lot of different times of the day, right? It's really complicated, right? How do you actually know? And I think we should know. I think that we should know. And I think that assuming that neighborhoods are going to be fine because you assume that they're relatively quietly trafficked or whatever. We just make a lot of assumptions for not placing a sensor in a particular location. But I think it is a regulatory question. I think we have to have measures for everywhere. And in the US, I don't know, is Waze a thing? I don't drive in this country. But I don't use Waze in the US either. But I mean, the thing is, you have a lot of these little tiny neighborhood roads that actually are getting a ton of traffic, right? So yes, it is a regulatory question, and that means that we have to be really careful and really think through. And just because you think a place probably doesn't have poor air quality doesn't mean it doesn't. And then, so when I started this, actually, I was coming at it from much more of an epidemiological perspective. What I wanted were measures of exposure to poor air quality for different groups. And I thought, if you knew who's coming in contact with poor air quality based on these sensors, then you could start to construct measures of exposure to poor air quality. But it turns out that for a lot of mobility data, we don't actually know who's doing the moving. So that's not great. And also, there weren't sensors. I looked at the locations of sensors. I was like, oh, this isn't quite what I thought the network was going to look like. But that was sort of where I started. But we can solve all these problems. It just, you start slow and you sort of figure out, you chip away at it and you figure out well, what could we do that would be better? And then you try that. And that's how science works.
Thank you for interesting talk. I am glad that I asked this question toward the end of the Q&A session because my question is quite a general one. As a smart city researcher, how do you feel about the term smart city? Because I got the impression that increasingly people are starting to abandoning this concept.
Yeah.
Probably because people equate the smart city with with more sensors and more control and more monitoring, and the people don't feel comfortable about it. So people are making up new concepts like a digital infrastructure city and digitally integrated cities and all these weird concepts to continue their research about smart city without
Yes.
using the term smart city. So how do you feel about this?
Yeah, I think you're right. That's how how do I feel about it? I don't know. I mean, it captures the imagination, which is probably what it needed to do in a moment. Unless the data that are being produced from sensors can actually be used for something, I think they're just like everything else that cities do to market themselves. I guess that's kind of what I thought smart cities were. I thought they were just another form of city advertisement and marketing. But I think that the digital infrastructure piece, that's here to stay, which means that we have to think about it. But yeah, I agree. But this smart piece, there's something about that word smart. I mean, ESRC has an investment of like £50 million into what was digital footprints data, and before that was called new and emerging forms of data. That program changed its name like 6 months ago to be smart data research. That's what they are, which I find interesting because I think as soon as we say something is smart, people tend to think it probably is not. But we really like that word. I don't know. You like it. You like smart cities. Ah, well, okay. Well, I'll save that for when I have a glass of wine in my hand because I.
Yeah, thanks for your talk. So I guess another broader question. In your travels, have you ever seen examples of bringing together different forms of data? So we focused on air quality in this discussion, but say like spatial transport provision or policing or so for instance, crime rate and stuff, data, different forms of data and bringing that into decision making.
Like for air quality sensors?
Yeah. Just bringing it all together, for instance.
Like how would the crime inform the...
So you may, for instance, if you have areas where there are, say, high rates of crime, what's the air quality look like? Is there a correlation? Are there areas of deprivation? I'm sort of trying to map areas like that.
But see, this is the thing. Like, don't get me started on crime. What is crime data? Crime is reported crime. As soon as you start to unpack it, you'll feel very uncomfortable with crime data for the rest of your life. So don't do it if you really care about crime data, because you'll feel sick. A lot of these measures that we rely on, I mean, think about the index of multiple deprivation, right? It is still a conceptualization of how are we going to measure this thing that we think exists, which is deprivation? But we have these constructs that we're forced to work with, and it's very difficult for us to think about the other constructs. And because we don't think about what other constructs might go into deprivation, we don't collect the data that then allows us to measure it. So, usually we say, well, this is the data that I have to work with, but data is socially constructed. We decide what we're going to measure and how we're going to measure it. So no, I have not thought about that. But I would say the problem is that you start to stack. It's the same question with air quality. Like if you don't know that the air quality is poor, you don't know to sense it, and you get this sort of circular problem. We have it with almost every other variable. I think it's challenging, and that's why we think a lot about data and how we're going to measure things, and yeah. But I'm happy to talk about it more. I feel like I didn't give you the answer of like the stacking lots of different variables. I didn't mean to be facetious, but yeah.
Great. Rachel, thank you very much for answering all our questions, and thank you to everybody for attending tonight. And thank you for your questions as well. You can ask more questions. I've just tried the wine. Not tried it. It's cold enough. I didn't bring any ice, but it's okay. So please enjoy the refreshments afterwards. But could you just join me finally in thanking Rachel again for her contribution to our series?